Excellent. All right. Hey, everyone. Thanks. I know it's the last session of almost the last day. We've got a bit of time together, so thanks for coming. So I'm here. My name's Pieter Humphrey. I'll introduce myself in a moment. But yeah, here to talk to you about CloudFoundry or Kubernetes and a little bit about choosing the right workloads and for the right platform and what that means for developers and operators. So real quick, who is using Kubernetes today? Could you just raise your hands? It's a little bit of a, right. Okay, a few people. Who's using CloudFoundry today? Okay, a few people. All right. Well, the rest of you, just shout out at a few things that if you didn't raise your hand to either of those options, what are you using? AWS, Bare Metal, Azure, GCP? Don't all jump at once. All right, I'm just curious. No big deal. So I'll introduce myself real quick. So I got said, my name is Pieter Humphrey. I have the privilege of working on the Spring team with smart folks like Mark Heckler here up front and original gangster Thomas Riesberg, who's hanging out there in the corner very quietly trying to be unobserved. And I'm the Spring Central Twitter handle. I do a lot of the marketing for the Spring team, organize conferences, that sort of stuff. So one of the first times I've been able to speak at Devoxx, so I'm excited to be here. And wanted to know a little bit more about you. So again, show of hands, classic 3-tier monoliths. Is that what you develop for the most part? Okay. Modular monolith, a la Simon Brown. Okay, great. Anyone doing cloud native, full-on microservice? Okay, yeah, great. Yeah, I know you are. Any function as a service fans? Pure functions. Okay. All right. You guys are always on the cutting edge, aren't you? So, as you can imagine, companies really do have a lot of ways to package and run their workloads on the cloud. So, greenfield apps, a lot of times these are going to be, you can choose the latest modern technology, right? Greenfield apps, maybe you can run microservices. Spring Boot is a pretty popular choice these days. Brownfield applications. Often, these are ISV applications, packaged applications. A lot of times these days, it used to be you'd get them, as a zip file, tarball, or an install shield installer. And people are moving away from that, right? Sometimes ISV applications are even delivered as Docker containers these days. A lot of those applications require stateful storage. They have clustered workloads. Maybe they're requiring specific ports to run on, this sort of thing. Often this is sort of the lift and shift use case, right? And so batch admin type workloads are another popular one. Like I said, event-driven functions, Lambdas, very most recent entry onto the scene. You have to know how you want to trigger functions and run them on the cloud. So maybe you even data services, you're running databases, or you're running Mongo or NoSQL databases. So there's a lot of ways to get to the cloud, right? There's a lot of different type of workload that people are working with these days. So most of our clients, at least at Pivotal, and I think most of you, your goal is what? To pick the right runtime for each workload. So are you going to maybe go direct to a virtual machine, directly on an IaaS, like AWS or GCP or Azure? Or maybe something higher order is appropriate. IaaS is pretty low level these days, ironically. I mean, it's good enough, but containers certainly becoming a very popular option, right? And there's a lot of container orchestrator offerings. I think the popularity of Kubernetes has really driven most of the major clouds and a lot of the software vendors to offer some sort of container management service. Certainly with Kubernetes lately, you're seeing, I think pretty much every major vendor now has some sort of container management service. Or are you going to go full application platform? Historically, I think we've called these PaaS, right? Platform as a service. Or the container orchestrator being container as a service. And then the most recent entry, serverless, right? The idea is to pick the right runtime for each workload. So let's look at that as in a slightly different way. And what does that actually mean? So if you're looking, let's start at the left, okay? What are you, the developer, what do you feed into this input? If you want to deploy your workload as on a container management system, what does that actually mean? So your input to that equation is typically just a container, right? Docker file or some other sort of Linux container image format. Platforms, that's like sort of one level up the abstraction tree, right? It's higher level. There's more guardrails. There's less flexibility, but there's more productivity. So you're not really in the business of building or maintaining or patching the container at all. You just supply your app to the platform, and it takes it from there. Maybe that's a binary, or maybe it's a Git repo. Depends on the nature of the platform. Sometimes they're different. And then the app platform will provide the rest of it. So it'll help you build the container itself, handle things like the level 7 network, routing, logs, metrics, monitoring. This is all sort of done for you automatically. So, and then going another level up, functions, right? So there you're building on a container orchestration and a platform, and all you're really doing is providing a small part of an application. And you're delivering maybe the context around when the rules under which it is to be executed. Maybe some context around that function, when to trigger it, right? So you're not even providing a full app, as it were. So I'm going to focus in this talk, I'm just going to focus more on these two on the left side here, the container orchestration and the application platform, because the title of the talk was Kubernetes and CloudFoundry. Maybe next year I'll come back and talk a little bit more about Lambda and serverless offerings as well. But I'm going to stay on these two left side for the time being. So as you move over to the right, things get less complex for you as the developer. There's less moving parts. There's less things for you to deal with, right? There's less tools, and you get more efficiency as a result. The more to the right. The more to the left you're going, it's lower level, right? So what does that mean? It means it's more flexible, but there's not as much productivity right out of the box. There's not as many guardrails, right? There's not as much done for you, because that's how the flexibility comes into play, right? Less on the rails, as it were. So let me just look at that from a slightly different perspective. Just basically restating the same point, but just look at it slightly differently. I mean, hardware, that you can do anything on top of bare metal, right? That runs all of IT's workloads, 100%. Anything you can imagine, you can install and run on hardware. But it's the most work, right? You move up one level, you're on IaaS. Maybe you get 80, 90% of modern IT workloads you can run in a VM directly on IaaS these days. But again, you have some constraints to deal with, right? Move up another level, you get to the container orchestration. Now you have progressively even more restrictions. Now you have to expect an ephemeral file system. Well, you probably had to expect that before inside a VM. But you have even more restrictions that you need to deal with. Again, another layer up, application platform. Even more restrictions, but more productivity until you get all the way up to serverless. The strategic goal, I think, for any dev organization or company should be to push as many of the workloads to the top as possible or as technically feasible. But again, title of the talk, how do you choose the right abstraction for the workload you have at hand? Because no one of these really is best suited for whatever unit of work you have in front of you, right? There's always an optimal choice. So let's, as we're talking about any kind of platform here, whatever platform you choose, however you're going to deploy code that you've written, you're going to be dealing with operating it at some point, right? DevOps is here to stay. The idea of infrastructure as code and you as a developer needing to be concerned with infrastructure and automation, this concept is not going anywhere. It's here, and we need to get used to it, right? So we separate these two, what I'll call operational challenges, into two wide groups. There's the stuff that you have to do the day you install the software, the day you set it up, right? So that's your build. Then on the second day, after you've got the environment set up, then you're into the operations stage. And you have different challenges at each phase, right? So day one, how do you get something set up maybe that could either is already multi-cloud or leaves that possibility for you? How can you get CD pipelines, CI/CD pipelines set up, so you're not doing manual release processes that are dangerous. Take up the whole weekend. Who's had to deal with the situation of, hey, it's time for the big bang release. Let's cancel our plans this weekend because we're going to be on call if things go off the rails. Anyone had to babysit a release over the weekend? Yeah, a couple of you. Okay, not a lot of fun, right? Not something any of us would really like to be doing. How do you get the consistency in the environment installation? Here's another case for CI/CD tooling, but shell scripting, etc. But how can you get some kind of consistent setup experience? Right? How do you get some leverage there? And then how long does it just take to set up? Do you have 500 pages of instructions to get through, or can you script it? Can you make a pipeline to do it for you? So ideally, you want this to be happening in hours, not weeks. So before getting this demo environment set up for today, I had to go through a fair amount of documentation just to get CloudFoundry running on Google Cloud Platform, right? I was sitting there, let's say Wednesday last week, preparing for this, and I'm looking at 50 pages of installation instructions, and a lot of it is like IP address ranges and CIDR notation, and I've forgotten that stuff years ago, right? So I have no idea what I'm doing, trying to figure this out. Fortunately, one of the other toolsmiths at Pivotal had written a concourse pipeline to help install CloudFoundry for me on GCP. Great, because I wanted to focus the talk today not on how I installed GCP. That's kind of boring, right? This is infrastructure. To me, this is below the value line and stuff that I don't want to care about so much, right? I've completely forgotten CIDR notation and IP address range conventions, right, for example. And I don't really want to remember them either. It was a scarring experience the first time. So day two, let's say, great, you muddle through, you get an environment set up. Now you've maybe deploying some applications to it. Now how do you operate, right? How do you do this thing long term? Well, there are vulnerabilities in software, right? There's patches that you're going to have to deal with at the operating system level and at the application library level. Spring people, we'll produce library fixes. Everyone will. In the U.S., you've probably heard the news from this company Equifax, right? That got hacked with the struts bug. So it's important, right? How you operate this stuff and how you patch, it should feel normal. And especially if you're at big enterprise and you have hundreds or worse, even thousands of applications. How the heck are you going to manage that? So scaling, how do you scale up, right? How do you upgrade new versions of both the application, the operating systems, or maybe even the platform while maintaining uptime, hopefully? And then operating the platform, ideally you don't want to have a staff of 10, 15, 20 people dedicated to operating it, right? This is the classic model from 10 years ago where you have a WebLogic or a WebSphere and you have a separate ops team that really knows absolutely nothing about the code you just wrote. So when something bombs, what happens? Who do they call? Right after Ghostbusters, they call you because you're the only one that understands the Java exception that got coughed up from the bowels of the application, right? Most operators are going to go, oh, I don't know, hello. So let's cut out the middleman, right? Why bother with that? This I think is the essence of the DevOps concept. So, all right. So generally speaking, platform challenges, right? So let's get more specific. So the two platforms that I mentioned at the beginning of the talk, CloudFoundry and Kubernetes, let's talk about each one in turn. So CloudFoundry this is where this is your mindset, I think, when you approach CloudFoundry. You're saying, hey, I just run this app for me, I don't care how. I don't want to deal with the platform details. Do it for me. I'm going to feed you a binary, or maybe it's a Git repo or something. In the case of CloudFoundry and the Java build pack, you feed it a jar file or a container, a Docker image or something, and you say, just run it for me. Provision the DNS, get the application instances up and running, handle the lifecycle management. I'm not interested, right? I don't need to manage all these knobs and dials. So maybe in this case, the platform is going to take care of creating a container, and you're not going to have to do source to image, or you're not going to have to go to Docker Hub and download something and then monkey with it until you're happy with it, right? In the CloudFoundry metaphor, Build packs, a la Heroku, which come from, 2012? This concept's been around for a long time. Build packs build a container for you, and you know exactly what pops out of that process every single time. There's no ambiguity, right? You know what level the operating system is. You know what version of Java it's running. You know what version of Tomcat is in there. Even if I have to pop in a new relic agent, right? You know exactly what's going to come out the other side of that process. Sometimes you go to Docker Hub, grab a Docker image, and it's like mystery meat, right? What's inside? I don't know. Hey, wow, somebody left a copy of Erlang in there. What the hell, right? Or more commonly, nobody bothered to slim down the Docker container, so it's fatter than a VM, right? In terms of all the cruft that's in the operating system. Anyone seen that movie before? Yeah, okay. 2-3 gigabyte Docker image? Wrong. You're doing it wrong. Go do it again. Right, so, but the platform should give you out-of-the-box logging, metrics, tracing, things like monitoring. The point is not a lot of additional configuration required, whatever the features are that it gives you. And then you should be able to create and bind to external services off the platform on demand. Ideally, not having to open a ticket, right? You want to be able to call an API and get access to a database rather than ask the VMware administrator for a MySQL VM that takes a week to provision. You just lost a week, right? If you could do it right then and there, boy, wouldn't that be nice? So the other thing, of course, operations. Being able to operate things consistently, reliably. Like I said, pipeline-based deployment so that you can speed up the rate in which you are pushing code to production, scaling things up, patching and upgrades. So in CloudFoundry, this is powered by BOSH. I'll talk about this a lot more, okay? And then I'll get to Kubernetes. So BOSH, what is that? Anyone heard of BOSH by just curious? Okay, well, hey, awesome, wow, all right. So I'll tell you, great. So then I'll tell you a quick little story about BOSH, very, very, very short. If you haven't heard of it before, this is what kind of complements a container orchestration engine and provides release engineering, deployment capabilities, lifecycle management, monitoring, managing the embedded operating system inside the container, that sort of stuff. So at Google, Kubernetes is meant to run in tandem with something called Borg. Anyone heard of Borg before? Okay, so Borg is Google's, this obviously predated BOSH. BOSH is actually Borg++. So kind of a funny little coincidence there. You take Borg plus one letter in the alphabet is what? S? Plus one letter in the alphabet is H. BOSH is literally Borg++. So we hired this guy, a few guys away from Google very early on, like 2012 timeframe, some really top flight SREs that were involved in making Borg. And they said, we love Borg, we like the concept, it does a lot for us, but we want to do it better. We have some improvements we want to make. And that's the genesis of this BOSH tool. This is the backplane of the entire CloudFoundry system. And as you will see very shortly, it's also becoming the backplane for Kubernetes. It's the way it works at Google, and that's going to be the way it works at Pivotal as well. This BOSH is handling tasks of the variety that you see here on the right. Okay? So it's a very wide scope. It does quite a lot. I won't read you off the slide, but I think one of the things I'll focus on for the moment is the health monitoring and the self-healing, which is pretty cool stuff. Let's see. Actually, I'm just going to take a quick break from that and show you one thing. Just use this diagram as a quick analogy. Kubernetes would kind of map to this part of CloudFoundry, being the container orchestrator, and BOSH is where you take a very, very, very important design decision where you're saying, I'm going to embed the operating system inside the release management and the cluster manager, not inside the container and have a bunch of snowflakes. So why is that so important? Because what it allows BOSH to do is repave fleets of VMs with zero downtime, right? If I get a CVE from the operating system level, we work with Ubuntu and Canonical, which, by the way, I have to admit, those guys are amazing. They turn around CVEs sometimes in a matter of hours. And we've been able to turn them around through our updated stem cells to our customers in a few hours as well. We had one customer who has over 2,000 application instances running on CloudFoundry as containers. They repaved their entire environment with zero downtime in less than 5 hours and deployed a new fix. Pretty interesting capabilities in that regard that you, as the developer, don't really need to be that concerned with. So that's pretty cool. The operating system management. Not a fun business for anyone, really. You know, what kind of value do you get out of that? But I want to focus on the health monitoring a little bit. CloudFoundry provides a couple levels of high availability. So your app instance, your container can fail, and CloudFoundry will just make sure that it comes back, right? Your process inside a VM can fail. CloudFoundry will detect that and bring it back. Your whole virtual machine that's hosting a number of containers could fail. CloudFoundry will bring that back as well. Or you can even set it up so that it fails over from availability zone. If you lost the entire AZ, you can set it up so that it will load balance and just cut right over to the other availability zone. So your applications that you're running are protected at least 4 levels. Now, Kubernetes, bit different. Kubernetes, your default mindset is a little different than when you approach CloudFoundry, but for good reasons, right? Kubernetes maybe is you're thinking, okay, I have a containerized app. I want you to run it for me, but I'm going to tell you how I want you to run it. So I'm going to be explicit about it and take the time to do it because I care about the details, because in this case, for this workload or this application, the details are important. I need the control. So this is where, you know, prepackaged applications from a software vendor, or maybe you have things that are cluster aware, like databases, or I don't know, so anything that's replicated in a cluster, really, like let's say old school WebLogic server running in clustered mode, or the much more common case, stateful, dealing with application state, databases, right? Things like Mongo or Cassandra Spark. The demo I'm going to show you in a few minutes uses Elasticsearch. Any Elasticsearch users in the audience? I'm just curious. A couple people. Okay. If you've not used Elasticsearch before, guess what? It's a search engine. Shocker. Didn't mean to spoil the movie for you. But customization is sort of, you know, how am I going to deploy it exactly? What ports are going to be open? And how am I going to operate it to maximize the performance and the reliability? So this is, you're in the driver's seat a little bit more. I think you get the idea. But the thing with Kubernetes is that there's a reason why Kubernetes ran in tandem with Borg at Google and why it runs in tandem with BOSH at Pivotal. Because Kubernetes is not exactly easy to operate. And if you are sort of lucky enough to be working at a company where they believe in DevOps and they believe in things like CI/CD, you're on the hook for some of the operations, aren't you? Right? So this, you know, this starts to matter. Kubernetes, you know, it's a great piece of software. It just doesn't address these sorts of things that you see on the slide. Doesn't provide the high availability. So I believe master and etcd nodes are not HA by default. Can't really, you know, scale the pod service within the nodes. Or excuse me, it does handle the scaling of the pod service, but doesn't really scale masters, the Kubernetes master node that hosts the API and the etcd VMs. And etcd is where Kubernetes stores most of its application states. And then things like health checks and healing, upgrades. You know, who manages this system? You know, upgrading a large fleet of Kubernetes clusters can be very difficult. This is just sort of out of scope, right? It's not a knock on Kubernetes. It just doesn't. It's just not in scope. So we're partnering with Google pretty heavily, and also VMware, and our own engineering, releasing something called Project Kubo, which was announced a little bit earlier this year at CloudFoundry Summit in Santa Clara. So we're going through some branding stuff there, but the idea is that we're going to run Kubernetes on top of BOSH and provide that missing experience and provide those missing features so that you can do highly available Kubernetes clusters on any cloud, right? If you think back for a moment to this diagram, and I know you may or may not be familiar with CloudFoundry, but at the bottom here, one of the other things that BOSH does is it disconnects you from the underlying infrastructure as a service provider. So in the case of VMware, that's vSphere, right? OpenStack, if you're running on-premise. If you want to run on open, if you want to run on public cloud, it's going to disconnect you from GCP, Azure, Amazon Web Services. Now, when I say disconnect, what do I mean? Anyone care to speculate on what they think I mean by that? Okay, don't all jump at once. What's that? Well, sure, but I mean, concretely, what are we disconnecting? CPU, RAM, disk, network. This is the basic primitives of IaaS, right? Not necessarily the higher order services that they provide, like Google's TensorFlow or something, right? So that gives you the portability across clouds and allows you to basically take Kubernetes clusters and say, I'm going to run Kubernetes on top of Azure or other unlikely combinations. So that's going to, like I said, address your day one build type of concerns, where it will help you deploy the environment and hopefully do it a lot quicker than having to do it manually, right? It took me, let's see, after I ran the automated installer for the pipeline installer for CloudFoundry on GCP, which took about 3 hours to instantiate all the VMs and configure everything. Getting Kubernetes running on BOSH took about another 2-3 hours just because I had never really done it before. Sort of first pass through. So provisioning, it definitely made it a lot less painful. In fact, I had a whole bunch of other provisioning to do just to get the demo to work. If I show you really quickly what some of that was involved there. What else do I have? So this is the CloudFoundry instance that I have running for the demonstration. It's running on top of GCP. And let's have a quick look at the installation dashboard. I've got a few products installed there that the demo application will use. And I'll take a break and describe that in a minute. Right. So I've got a couple things all set to go. I've got the CPI for Google Cloud. Elastic Runtime is the core CloudFoundry. And then I've got tiles for Redis, RabbitMQ, MySQL. But rather than have to download it, set up some sort of Docker image and fiddle with it all, literally I just download a Pivotal file, import it here, and then when you click into the tile, you get the opportunity, you just have to configure it and say, okay, I placed my data center in Google US Central 1A, and configure it here through this kind of walkthrough, and you set up the plan settings. So the idea is that developers can self-service these environments, right? You provide a marketplace in CloudFoundry, and then you're not having to open a ticket as a developer and wait for a VM. It's an API call, and it happens instantly, right? But this sort of setup allows the operations staff or the more senior people to set up the possible universe, right? So great, yeah, I've got Redis, but I don't want to let someone provision a 200 gigabyte, Redis instance, right? No, I don't have that many resources, or I don't want someone to do something that expensive. So you create plans, and then the developers can consume those. Hopefully this makes sense. Just wanted to show it to you so you get the idea. Point is, it's a bit easier doing this and having BOSH handle it, all the implementation for me, than me physically downloading Redis and setting it up on a VM template or something. And then, of course, you still don't have the sort of control over the self-service provisioning. It's just what's in that Docker image. And you can't necessarily prevent a developer from provisioning the Docker image and then assigning, an insane amount of resource to it, disk or memory. Okay. So that's the build part, right? Let's get it set up. Give me an environment. And then, like I said, the operations, what happens after the fact, once you start running it and deploying things to your Kubernetes clusters on top of BOSH. So that's where you're going to appreciate things like the ability for these VMs to self-heal and for BOSH to monitor these VMs or containers and be able to have elastic scaling for clusters. Be able to do things like rolling upgrades, high availability, and support multiple availability zones, even across availability zones. So this is the open source project that we're working on with Google and VMware. Excuse me. And then we are commercializing that. This is sort of Pivotal's thing. We do a lot of work in open source, and then we provide a commercial product on top of that that uses the exact same open source bits, but has some commercial value add. We frequently could just call this an open core strategy. I'm sure, hopefully that's a term that's familiar to most people. But idea is that it's the same bits as the open source plus some other stuff. So that other stuff, in this case, what does that mean? There'll be the commercial version of this would be something called Pivotal Container Service, with a little nod to Google GKE, where the K is container with a K, I guess. Maybe it's Kubernetes. I'm not sure. We don't know really, but that's just going to give you the dial tone, effectively, to use a telephone metaphor, on Kubernetes, where here's the health management, aggregated metrics and logging, so you don't have to SSH into 5 million containers when something goes wrong. All the logs get aggregated for you, so you have one place to go. And dealing with things like auto-scaling, volumes and persistence interfaces. And of course, providing the control plane. But there's still things missing here, right? What if you probably want some sort of image registry for your Docker containers if you're using Kubernetes? They need to be security scanned in there, and you might even need things like controls around that, especially in a larger company environment. You might need role-based access control, right, to those container images. The other thing that Kubernetes provides you is pretty simple networking. It's a flat network, right? Everybody can see everybody. So in more complex scenarios, you might want to do dynamic load balancer provisioning, or have role-based access control for the actual networking bits. Or maybe you need to do more complicated microsegmentation of the network and not just have a flat. This requires some sort of overlay network or software-defined network. So that's a little bit where VMware comes into the picture, because they have a great software-defined networking solution called NSX, right? So we'll support that out of the box. So basically, the difference between the open source and the commercial is really just that Harbor image registry and the NSXT. If you want, not everybody needs network segmentation at that level, but it's available. It's there for you if you want it in Pivotal Container Service. As well, there's a GCP service broker out of the box. I'll talk about that in a second. And then of course the Kubernetes cluster itself, all running on top of BOSH, which in turn can run on any of these clouds. So that's just the quick what is actual Pivotal Container Service. Now, some Kubernetes users will want to slice and dice a single Kubernetes installation and make it multi-tenant. That's a very common use case. In fact, I think that's most frequent. But what we're seeing with some of our customers, especially the larger ones, is they will want they'll end up wanting separate clusters for separate workload profiles. And they don't want to have a single, all singing, all dancing, multi-tenant cluster. They want to break them apart. But the consequence of that is what? You have more, suddenly, fleets of Kubernetes to manage, right? So without something like BOSH behind it, it gets a little more difficult. The GCP service broker, this is what allows you to create BOSH clusters on demand. So you are literally just typing at the command line. Let's see, hold on. I'll show you my existing cluster real quick. kubectl get services. Oh, sorry, wrong window. So I have an existing cluster up and running, and I've got a few members here. kubectl get pods, so you can see some of the instances. Yeah, so I've got a Docker image for Elastic and Kibana, and then a little Maven repository that I used for just taking some files so I could access them via HTTP. I'll show this to you in the demo in a few minutes. But for services, CloudFoundry is very simple. Let's have a look at some of the different services that are available on this installation. Come on. You can do it. All those little mice running around in the cloud spinning the wheel are getting tired. Come on, folks. Okay, well, I'm just waiting for that to return. Creating it is almost as simple. Once you have it set up inside of CloudFoundry and you have the plans provision and that sort of stuff, then for the developer, creating a Kubernetes cluster is literally not much more complicated than what I just typed. CF create service. Name the service and choose the plan. So it's about that easy to create a Kubernetes cluster. If you do that without BOSH, well, it took me... I mean, some people even like to, if you talk to Red Hat, they'll tell you to install Kubernetes on bare metal. That takes quite a while, right? It's certainly not CF create service and then have something. Did I lose internet connection here? Hold on 1 second. No? Okay. Well. There we go. Yeah, so this installation, there it is. There's my Kubo cluster, my Kubernetes. And then I have a Redis, Rabbit, MySQL, and just like another database for a different demo already set up. But again, this service is provisioned by the service broker. So that's what this square up here on the left where it says GCB service broker. That's what that does, right? It allows me that interface so that I have a simple way of provisioning clusters, and I can do it via the CF command line. Great. Okay, so hopefully that gives you a bit of a flavor for what I mean now when I say Pivotal Container Service and what the difference between the open source bits and the commercial is. And then in addition to provisioning, you can use the service broker to deprovision environments and scale them and configure them for the marketplace. One of the other cool things about the partnership with Google in particular is going to be the constant compatibility. So Kubernetes releases pretty frequently. Right now, it's somewhere around every 3 months, sometimes more often. So that's a pretty quick pace to keep up with, right? How do you keep up with that release cadence and still be able to do things like rolling upgrades without downtime? Well, how do you deal with security patches? Again, that's where BOSH will help you, right? So when Google, the nature of the agreement we have with Google is that when they deem a Kubernetes release stable enough to run on their cloud as GKE, Google Container Service, it is instantly synchronized and reflected with what we offer with Pivotal Container Service. So you can have confidence that you're always running the latest and greatest Kubernetes. And with something that is still relatively young and releasing that quickly, that's pretty important. You want to make sure you get the latest features. You want to make sure you have something that was approved, tested, or blessed by Google in some way, right? They are certainly the majority of committers on the Kubernetes project. Okay, so that's interesting. Now, how does this all relate back to the title of the talk? Choosing the right workload for the right platform, right? We think that people, especially the Pivotal customers, will probably end up leveraging more than one abstraction. So CloudFoundry and Elastic Runtime, or as we now call it, Pivotal Application Service, is great for a service tier, right? Fantastic for that. That's where you want your stateless web apps, your REST API layer. That's where you want that sort of thing to live. Inside of Elastic Runtime, managed by BOSH, leveraging various platform services. Pivotal Container Service, or Kubo, this is a great way to deal with more stateful workloads, Things like databases, things like Elasticsearch, maybe, like I said earlier, a WebLogic server running in clustered mode or something like that. Now, how do they work together? I mean, like I said, the broker is a uniform experience, but we're working to integrate the networking as well. So if you declare routes in your Kubernetes cluster, that they'll be synchronized if you have the CF route sync configured correctly. It will allow you to expose those Kubernetes routes directly to the CloudFoundry Go router. Or you can just bypass that and use the typical Kubernetes routing without the integration. So that I do have it set up this way for the demonstration, so that the routes that I have set up with the labels in Kubernetes are going actually through the front door of CloudFoundry. so their routes are synced. So let's talk about this use case. I've got some Spring Boot apps basically running as my service tier on Elastic Runtime. In this case, it's something called Spring Cloud Dataflow, which I'll explain a little bit more in a moment. But they're essentially Spring Boot apps. Do we have any Spring Boot users in the audience? I'm just curious. A few? Okay. Just Spring users in general? Java EE? Something else? I guess you would have to tell me what that is. But I figured that it seemed like most everyone in the room is on one, other, or some combination of those things. So, great. Service tier running over here on the left side. Right? You with me so far? Then on the right, the demo, I've got Elasticsearch running inside of Kubernetes, inside of a Kubernetes cluster. I'll talk about Spring Cloud Dataflow in just a second. So let's see what this looks like in action a little bit. Now, Elasticsearch has this cool little demonstration that they have published on their website, example workset on earthquake data. So they are using ANSS data from the Northern California Earthquake Data Center. So it's a nice little data set. What does it actually look like? When it comes right down to it, hold on one second. There we go. This is basically a bunch of CSV files delimited by a star. Right? So this is just geospatial information about where the earthquake was and the magnitude of it and that sort of thing. Now, using Elasticsearch and Kibana, I can visualize this in a dashboard. So what I'll do is just, let's get started here. Let's see. There's the create index. Okay, so first thing I'll do is I'm just going to create some indexes in Elasticsearch. And there we go. Okay. Yeah. Let's make sure this is turned off. Yeah, so I've got to turn that off. Okay. Just bear with me for 1 second. So I'm going to start by creating some indexes. This is just the create index script is not doing anything too crazy. Create index is just basically doing a curl, and then it's dropping in some JSON here to configure some new indexes and drop the existing data. So now in Elasticsearch, which I have over and Kibana, over here. Now I have kind of a blank dashboard with no data at all. So I've just set up some indexes. That's it, right? Okay, so how do I get this back and actually showing me some earthquake data? Well, let's do that. So, let's look a little bit at some of the components of the system. I'm going to enlarge this a little bit so you can read it more easily. Okay, so on CloudFoundry, I said, as I was saying before, I've got a couple different apps. I've got this Dataflow server here. These are all Spring Boot applications. Dataflow is is something that's built on top of Spring Boot that allows you to do data pipeline processing, and is essentially kind of the core integration architecture that you can build multiple integration initiatives off of. So right now, I'm just going to go in and delete the streams that I had so that I can show you recreating them. Let's get rid of this guy. Now, the nice thing about the integration between Dataflow on CloudFoundry in particular is that each little component is just a separate boot application. So once I delete that stream from the server, if I go back here to CloudFoundry and I ask it what apps are running, look, all these are gone, right? So this is the cool thing about Dataflow is that as it implements steps in a pipeline, just each little step is a separate boot app. So this is true microservice architecture in action, right? Because if, let's say I need to scale up committing data back to Elasticsearch, all I need to do is scale up that one boot app, right? I'm not horizontally scaling a monolith and wasting a lot of resources. So, Right, so just deleted the stream there, and what we can do is let's take a peek at some of the other components of the system real quick. Right, yeah. Oh yes, of course. I think I showed the kubectl a second ago. Right, and this was just a very, very simple, like I said, very simple Docker container that's running Elasticsearch. This is my Kubernetes cluster, and then I had a Maven repo that's just, its only purpose is actually really just to serve a few files for the purpose of the demonstration. I could have used a static web server build pack or something like that if I wanted to. But all those data flow components are removed now that I have destroyed the stream. Right. The stream is what's going to get me from, and data flow's purpose is to get the data as an input from this file into Elasticsearch. That's its role in this architecture. Right. It's pretty simple, but pretty simple for the purposes of the demonstration. But for this is a pretty generic application tool set that you can use for nearly any integration scenario. I'm just going with something simple here. So let's take a look at how this plays out. So the nice thing about Spring Cloud Dataflow, one nice thing about it, is there's comes with a DSL, domain-specific language, that you can use to define streams. So if I go over here to create stream and drop the definition into the editor, it sort of lays it out for me. I can do it via command line as well if I wanted to. There's a shell for Spring Cloud Dataflow. And you just run the shell jar file and then target it at your installation, and then you have a non-compiled dynamic shell experience where you can kind of tab complete your way through things, create streams, destroy them, manage their life cycle, and implement custom actions. More senior developers can extend the system and create verbs effectively in this DSL. For more junior developers to work with, they can just use the DSL and don't have to bother with a more complicated language like Java, perhaps. So let's run this stream, or let's talk about what this one's doing. I'm going to bring this delay down to 1 minute. And then all it's doing is, after waiting, it's just going to call a URL, make an HTTP call to go get that earthquakes text file. And then it's going to start parse it for you. That's what the splitter is for. So it's just saying, hey, separate everything out via the star delimiter, and then let's sync it back into Elasticsearch data store. Now, you might very legitimately be asking yourself at this point, what's happening there? That looks like a little bit of magic. Let me just show you a little bit about how easy that one is. The Elasticsearch sync is just a Java class, and it's only a few lines of code. Basically, it's a Spring Bean. It's again boot application, and it's very similar to creating Spring integration channel adapters. I'm just defining a few bindings and auto wiring a few things, setting up a stream listener, and working with the payload a little bit. Then I have one other class to run it as a Spring Boot app. And then I have some configuration where I'm pointing it at the Elasticsearch URL, Elasticsearch server, and creating some getters and setters. So not a lot of development to create a sync for Elasticsearch out of Spring Cloud Dataflow. So let's see. Let's go ahead and create this stream now. And let's give it a name. I'd like to just deploy it straight away. Awesome. Okay, so now if I go back to the CF command line, the CloudFoundry command line, hey, cool, it's starting a bunch of servers for me, right? This is the nice part about the Spring Cloud and understanding how to work with CloudFoundry and platforms like this directly, is it just in turn, you are using this high-level DSL under the covers, it turns around and is just starting a bunch of boot apps that implement all that logic for you and make them independently manageable and scalable as microservices. So that will come up, take a moment. There we go. Now they're all started. We can look at them too in the GUI. We don't just have to use CloudFoundry as a command line experience. If you use Pivotal Apps Manager, you get a sort of GUI-driven experience. This is the CloudFoundry instance I have running on GCP, and there are all these same applications, right? Here are the ones that I just created. What do these actually look like? This is a piece of code without any user interface. So if I clicked on this link, it wouldn't take me to anything. But if there was an app that had some UI in it, I would just click on it, and it would take me right there because CloudFoundry generates all the DNS and all the routes. So, if there was a UI, it would just take you right there. So, the other interesting thing is that these components are bound to RabbitMQ. So, if you remember, it's a processing pipeline, right? Let's go back and look at that. Where was how do I see it again? Definitions, yeah, that's right. Okay. All right, so it's a multi-step pipeline. If each one of these is a separate Spring Boot app, then how do I get the input and output of each step from one to the other? Right? There's a network gap in between them. So RabbitMQ is going to bind to each one of these boot applications and make sure the input of one step goes to the output of the next and is reliably delivered, right? Because that's what RabbitMQ does. And then ultimately all the way to Elasticsearch. But again, you don't have to set it. This is nothing you had to deal with, right? This is all kind of managed for you without any development work. So that's why you see a RabbitMQ bound to some of these system components. So if I go back to the demo space, and same story for all the others, right? Okay, so I've got a stream deployed. Let's go back. What was it next? Let's see. Yeah. Okay, so right. So we talked through that. Now, if I go back to Kibana and hit the refresh button, those processing pipelines are already at work. There we go. I've got some data flowing into Elasticsearch right away. And then if I configure that sync correctly, every second I've got about 9,000 records in there so far. Every second or so, it should update, and I should get a few more. Yeah, there we go. See, counters continuing to increment, and the Kibana visualization is sort of progressively unfolding. Right now, again, just a quick reminder. This is all live data running on GCP, Kubernetes running on top of BOSH, again, in turn on top of Google Cloud Platform. No trickery here. This is all real live stuff, and this is my own cloud that I own and manage on top of GCP, and my own CloudFoundry that I own and manage on top of GCP. That's running the Kubernetes clusters and Spring Cloud data flow. So, yeah. I think one more. Maybe there's a little bit more data still coming. Let's see. Hold on. Yeah, okay. So it just continues to pipe in data to Elasticsearch and visualize it. Any questions at this point? I'm just going to take a quick pause. Anyone quick questions, or shall I continue? Okay. Stop me if you want. All right. So let's head back to some PowerPoint for a minute. Righto. Okay. Cool. All right. So before I was talking about a sample use case where you've got boot on the service tier and more stateful stuff or cluster-aware stuff running on Kubernetes. So I want to talk a little bit about that stateless service tier and why boot is such a good choice for that service tier, why boot apps generally work really well on that service tier. When you work with CloudFoundry, you're working with something called the Java build pack, generally speaking. Like I said, you can supply it a Docker container, but the boot apps are built by something called the Java build pack. This is a Heroku concept that's been around since almost 2012, where CloudFoundry has adapted it and improved it, and provides you some features like being able to support boot's self-executable jars, and it will even help you set the Java memory management settings. So if you supply a build pack, a jar file, it will take some nice educated guesses about what the memory settings should be and make sure that it's not going to barf as soon as you deploy it to CloudFoundry because you forgot to set the memory settings. It might not take you 2 years into operation with the settings. You probably still want to be a responsible developer and profile your application somewhat and tune the memory. But it can go a long way to helping you there. Also, what happens if the application crashes when you're in a virtualized environment? How do you get a heap dump? How do you get a thread dump? How do you get a heap dump out of a Java application on a container, right? The CloudFoundry, cloud platform may destroy the container before you can even SSH into it and find out what the heck was going on. That's been a sore point for a lot of people in the cloud running Java, actually. So there's some ways to at least get a histogram of the JVM heap, and so you can figure out what the expensive method was or what was running away with memory. Anyone ever worked with the @profile annotation in Spring? Okay. So this is a nice bucket for you to set your environment-specific variables. Any configuration you put in those classes, when you deploy to CloudFoundry, it just automatically enables the cloud profile for you. So that means you can change endpoints and port numbers and URLs without having to recompile or restage your whole application. I showed you the apps manager a moment ago for CloudFoundry. And it will work and integrate directly with Spring Boot actuators like the dump, the heap dump, the trace, that sort of thing. It allows you also to change the logging level of Spring Boot applications directly at runtime. And when you're running on that CF stateless tier, service tier as I like to call it, you may need, if you're doing microservice applications, you're going to want container-to-container networking of some variety. Right? You don't want microservices always to have a public IP address or publicly named DNS. Right? You want to get out of that business. You want them to be discovered dynamically. So these are basically the ability to say, I want certain firewall rules at the container level. I might need to communicate with another microservice running in another container on CloudFoundry without going all the way through the front door of the router and coming back, because that would give you rather large amount of network traffic. And then the other, probably the best reason is something we call Spring Cloud Services. With Spring's approach to microservice architecture today, we've done a lot of work to integrate the Netflix open source stack with not only the Spring programming model, but with that CloudFoundry service tier, that application runtime. We've worked, some of the more important ones are the configuration server. And like I said, Spring is giving you sort of the client side of this in your applications. CloudFoundry can provide a pre-built Linux virtual appliance that is right out of the box push button configuration server. So this is Git effectively as a network service, right? So rather than have the configuration embedded inside your application, where if it changes, it needs to be recompiled, restaged, redeployed, you're going to get it at runtime. And you're asking a HashiCorp Vault or a Git repo to say, hey, please give me the latest configuration and then push it out at runtime to various applications. This is very powerful and is a way for you to deal with more ephemeral environments like containerized environments where things may be popping in and out of existence. They're not going to have a static IP, they're not going to have a publicly addressable route. They're, in fact, going to get the information on where they are from a service registry dynamically. Again, another reason why containers might need to communicate directly. In Kubernetes, this is not so much of a problem. Kubernetes, again, has a flat network and does allow this sort of dynamic service discovery. But in CloudFoundry, we actually had to put some work in to make sure that container-to-container routing was something that was allowable in the system without having to go back out through the front door and hairpin routing. The last service that CloudFoundry has built in for Spring microservices is this circuit breaker. This is what's going to allow you to maybe make some compensating transactions or have a failover behavior in the scenario where a service is unavailable, right? Or maybe it's past one too many failure calls and it's starting to slow down. And maybe it hasn't crashed, but the performance is bad enough that it's starting to infect other services on the system. So at that point, a breaker is tripped, and no more. You'll no longer get traffic routed to it. So these are all built right into CloudFoundry, as well as things like metrics and distributed tracing. So if you're trying to troubleshoot and figure out what's going on in a complex web of microservices, being able to see the call stack is kind of helpful. right out of the box in CloudFoundry, you've got a nice user interface that will allow you to correlate the logs. So over here, you can see the call stack in the screenshot. And then with CloudFoundry, you're not SSHing into individual containers to find out what went wrong. It aggregates all the logs into a single stream. And if you just click on, let's say 10 seconds, what was happening there, it will jump you right to the spot in the correlated logs where that action occurred. So it's going to make troubleshooting quite a bit easier. This is based off of some work we're doing with Spring Cloud Sleuth and PCF metrics. So this is fully integrated with security mechanisms as well. And if you use Spring Boot actuators, you can get custom metrics automatically just display through this. So this is a very nice way to do some troubleshooting. Last, of course, you just get some basic metrics like network container app events. This is sort of the standard thing that you might expect just to see the health of the container overall. But in aggregate, these are a lot of just nice reasons to use a service tier that's designed for Spring Boot and use a tier that's designed for stateful services and clustered workloads in Kubernetes. If you've never tried it before and you want to get started, a Pivotal Container Service will be available later this year for you to try out. So for now, it's just the service tier and the Pivotal Application Service. You can try it on a public cloud, or you can try it on your workstation. There's a local dev version that you can deploy to. So that is pretty much it. I wanted to say thank you very much for the time you spent with me today. And I'll be around for a few minutes if you want to talk a little bit more about Kubernetes Cloud Foundry and ask me any questions. Okay? So cool. Thanks a lot. I know it's the last session of the day, and I'm probably standing between you and beer. So I want to give a few minutes back to you so that you can go get something to eat and go have some fun talking to your colleagues. So again, thank you very much.